The only real difference between a chatbot and an AI agent is that the agent can reach into your terminal and actually do the work. Think about coffee. A chatbot hands you the recipe and you make the cup yourself. But an agent walks into the kitchen and brews it for you. That kitchen is the key idea, because access to it is what turns talking into doing. For an agent, the kitchen is an environment plus tools, the terminal it can act inside, and the shell commands it can run. Under the hood, the brain is exactly the same large language model you already chat with. Nothing about its intelligence changed. To see why, picture a normal debugging session with a chatbot. You run your program, hit an error in the terminal, and paste that error into the chat. The chatbot says it needs to see your code and gives you a cat command to print the file. You run it, copy the output, and paste it back into the chat. It reads the code and replies with a said command to fix the broken line. You run that, then it hands you a command to compile and run the program again. Notice what actually happened. The language model did all the thinking, and you were just moving commands and output back and forth. You were the actuator, a pair of hands shuttling text between the model and the terminal, adding no intelligence of your own. So here is the reveal. If you write a script that does that shuttling automatically, you have built an agent. The terminal becomes the environment, and the shell commands become the tools. The pattern driving it is called the ReAct loop, and it is simple. The model reasons about the problem, emits one command, your code runs that command, and you feed the output straight back to the model. It reasons again with that new information, emits the next command, and the loop repeats until the model signals it is done. Real agents also need guardrails, security limits, and formal tool definitions. We will see them in detail in future videos. Let us build the smallest version that actually works, running fully on your own machine. First, install Ollama, the tool that runs language models locally. Then pull a small coding model, something like Qwen22225 coder at 1.5 or 3 billion parameters. We go small on purpose so it runs on a normal laptop with no dedicated graphics card. Be honest with yourself. On CPU, it will feel slow, and that trait is exactly why we picked the tiny model. Now the agent itself, in a short Python script with no guardrails and no logging, just the loop. We use a dead simple text protocol. The model either replies with RUN: and a command, or it replies with done. That protocol matters because parsing it is trivial, which keeps our code and our prompt easy to reason about. Our prompt tells the model it is fixing a bug and must answer only with a run command or done. When the model sends a run line, we execute that command with subprocess and capture its output. We paste that output back into the conversation, and the model reasons about what happened next. When the model finally sends done, we break the loop and stop. To demo it, we give it a C program with one clean bug, a missing semicolon. One clear error keeps the loop short and readable so you can watch every step. The agent runs the compiler, sees the error, and reads it. It emits a fix command to correct the broken line in the file. It compiles again, the program builds cleanly, it runs it, the output looks right, and it sends done. That whole fix happened with your hands off the keyboard, and that is the entire point. An agent is the same brain as a chatbot, but this time it was standing in the kitchen doing the work itself.